Now we're going to look at a program that accomplishes robotic autonomy, and it's in the form of what we call a line follower task. So you could imagine that you could put a line around an office building or through a school, and you would have this robot follow the line around. So we not only want to look at the algorithm on how to follow the line, but we also want to add into it multiple sensors into our program so that we can not only cruise along the line, but we can stop if there's an object in the way. So this gets us close to an autonomous task, because this thing could, or this robot could accomplish following the line and stopping when an obstacle is in the way without or with minimal human interaction. Okay, so you could imagine all sorts of things. Once you get this algorithm working, you can draw, put tape all throughout your school and have it run into each room within there and deliver mail, and then each person has a little book that they put in front of the line when they want the robot to stop, and then as soon as the robot stops and they want the robot to continue to the next room, you remove the book and it continues, and so this thing goes indefinitely. So here's our task. We are going to create a black line on a white surface, or it doesn't have to be black with the color sensor, it can be any color. And we just want a contrast. So we want a contrast of a line on a surface, and you can use tape. I'm going to use blue duct tape, and I'm going to put it on my desk, and we'll see if we can track that. And then we also want to do it so that it's not straight. So we want to make sure that there's some turns in there so we can verify that the program is actually tracking the line. And then we're going to create a program to follow that line. And we also want to add in a little bit of secondary sensing, which is we want to detect obstacles. So we're going to use the color sensor to track the line on the surface. And then we're going to use the IR sensor, or ultrasonic sensor if you have that instead, to detect an object. And when an object is on the line, what we're going to do is just stop, and we'll play a tone, and or just wait, and then as soon as it's removed, we'll continue. Okay? So before we actually start programming, we got to look at what this line follower algorithm is. So if you think about, we're going to have this line, which is great, drawn here, but it actually doesn't follow necessarily the line itself. What it follows is the transition between the two colors. So it's looking at the contrast here, and it's actually a really simple line, or a really simple algorithm, because what it does is, imagine you're over here and you are on the white surface, so the light surface. What you're going to do is just create a program that is going to slowly turn to the left, and then as soon as the sensor sees the dark surface, it's going to slowly turn to the right, and then it comes back over here, and then it's going to slowly turn to the left. And so if you were able to see exactly what the robot was doing, you would actually see it just kind of go back and forth around this transition. And it's kind of an interesting program because you have a lot of settings you can change. If you put your turns too sharply, so you have your motors on too hard to do these left and right hand turns, you'll really oscillate back and forth quickly, and you'll see your robot really move in sporadically. But if you dial it in just right, you can get it so that it'll actually just go right along this transition, and you can dial in these settings so that you can barely see that it's actually toggling back and forth. So that's the theory of the line follower. So let's go ahead and implement it. So bring up the Lego Mindstorm software, and what I'm going to do is I'm going to start a new project. And here comes our Lego Mindstorms, and you can see that I have drawn a line on my desk using blue duct tape. And this is something I can do because there's enough contrast on here with the brown surface of the desktop that it should be able to see that. And we can even detect this edge even more because it's blue. So what we're going to do is we're going to use the color sensor. We're going to use it to measure a color, and then what we'll do is we'll say, if you don't see blue, turn left. If you see blue, turn right. If you don't see blue, turn left, and it'll just continually toggle back and forth along the transition of this line. Okay, so let's see how we are going to do this. First thing I'm going to do is come down into my action, or my flow control, and grab a loop. So we're going to loop indefinitely. And then I'm going to come down, I'm going to grab a switch. So I want to get the line follower working before I add in the obstacle detection and stoppage. So okay, so now I have my switch in here. And what I want to do is I want to come in here and tell it we are now using the color sensor. And we want to compare, let's see what we're going to do. Let's see what we can do. We actually want to compare color. So let's go ahead and do this one. And what I want to do is I want to say blue, because blue is what I'm after here. So I'm going to compare blue, and if it sees blue, it's going to do whatever is up in this construct or this flow. If it doesn't see blue, it's going to do this. So if you remember, if we don't see blue, we're going to turn a little bit left. If we see blue, we're going to turn a little bit right. So we accomplish this by simply going back to our move tank, and I'm going to put this up in here, and let's go ahead and implement our right. So it sees blue, so it's going to turn right a little bit, and I want to do this pretty slow. I don't want this to overreact, okay? I want the corners fast enough when it turns right that it could take a corner, not just track a straight line. It needs to be able to react fast enough that it could take the corner, but it also, you don't want it overreacting so that it goes left and right too much and it really jags back and forth. So I'm going to go ahead and put on continually, and I'm going to slow this down to, let's go 50 on the left wheel, and let's go 20 on the right wheel, and we'll see how that works. And so this is going to veer to the right every time it sees blue. Then if I don't see blue, I'm going to go ahead and copy and paste that, and I'm going to come down here and I'm going to do the exact opposite turn. So I'm going to veer to the left. Okay, and that's really it. I mean, I have this great sensor which I can tell to look for blue. If I see blue, I'm going to turn a little bit to the right. If I don't see blue, I'm going to turn a little bit to the left, and this should track the transition between the edge of the blue tape and any other surface. Okay, so I'm going to go ahead and I'll go ahead and download this, and we're ready to test this. So I disconnect and I come over to here to my project I just created, which I should have called something really good, and it's off and running. And so here we go. So I'm going to start it right here, and let's see what happens. Notice how it's going back and it's tracking the line. It's going left, right, left, right, left, right. It's real subtle. And here comes the first big challenge. Can it turn right? It did. It turned right. And then can it turn left? And here comes another left-hand turn. And it did it. Okay? So here we go. Let's do that again. See how it's kind of moving back and forth? So that's an adjustment you can actually make. And here's the big challenge is it turns right. So if this turn would have been sharper, for example, it was too sharp, then what would have happened is it wouldn't have had enough turning strength to make the turn. So let me give you an example of a corner that's too sharp. So take a look at that corner right there and watch how it won't make that curve. So let's go ahead, and here it goes. It's tracking the transition very fine. And here it comes to this, and it's going to try to turn right, but it just can't quite make it. Okay, so this is where you would have to dial it in. So you have a robot and you're making your own course, so you can adjust the course accordingly, or you can change your program in order to be able to make the turn. So let's go back. Let's put it back to something that has a little bit gentler turn here. So it's tracking this. Everything's great. Let's see if it can make this turn now. It did. Notice that when it takes a left-hand turn, it's not that big of a deal because it can go way out and come back. And so there it is. So now that's fantastic. So we are following a line. It was a very simple program, kind of a neat algorithm, and it works very well. So now what I want to do is I just want to put in that final thing, which is to detect an object, and if it sees an object, let's go ahead and stop. Okay, so the object has to be on the line. So to do that, what I'm going to do is I'm just going to take a flow control, and what I want to do is I want to do a switch. Okay, now the switch is going to come up here, and it's going to be the first thing that I do. And if you think about, I'm going to set this up based upon the infrared sensor, and I want to compare proximity. So if it's less than, let's use our 10 like we had last time, and it's got port 1, it's less than 10, which is pretty, we could even do it. We could even do 5, but let's just do 10 right now. Think about what's going to happen here. If it sees something, you want to stop. So that's what we're going to do up here. So I'm going to go ahead and I'm going to grab a move action. And what I'm going to do is I'm going to take the move tank and I'm going to put it up here, and let's see what I'm going to do. I am going to actually take this and I'm going to say off. So it's just going to stop, okay? And we can have it either hard stop or coast. And then it's going to stop, and then it'll cycle through and see if the obstacle's still there. What do I want to do if there's not an obstacle? I want to follow the line. So I actually drag this entire switch construct into here, and this program gets really big really quick. So you have to zoom out to actually be able to see the entire program. And this is where you start seeing the drawback of a graphical programming interface, is that it's really good for simple tasks, but as soon as the program gets a little bit bigger, it's kind of hard to see. So there's our entire program. And so what I want to do now is I'm going to go ahead and let's download that. And we've used the ultrasound or the IR sensor before. We've got our line follower worker, so this should work. So let's go ahead and try it out. So I'm going to plug that in. And now what I'm going to do is I'll come over here and I will download it. Okay, so now let's see what we have here. First thing we'll test is just making sure the line follower works. Okay, so it's moving. And it's tracking the line. Now let's make sure it can see this. It can make the turn still. So it made the turn. And now look at that. It stopped. Okay. So this is great. So what I want to do here is let's go ahead and put an obstacle on here that might be commonly found. And let's make that a coffee cup. So here we go. So it's going. And here it comes, and we got this coffee cup in the way. And so let's see what happens when it turns and sees it. Doesn't even see it at all because it wasn't really in the way. So let's put it like this and see if it sees it here. It saw it. Okay, this is great. One thing to note, a coffee cup is actually kind of hard to detect because it's a cylinder, so the IR energy is reflecting in all areas. So a book or something flat would be better. But look at what happens when I remove it. All right, it continues on its way. Let's see if it can detect it over here. Makes the right-hand turn. That's good. It's going to make the left-hand turn. And it stops. Voila. So we did it. We have created a line follower algorithm. And you know, you think about this, it's pretty simple what we've done. But imagine this. I want to take tape and run it all over your school, all over your office building, and set this thing off. And maybe you could put something on it where it could carry things, carry mail around to everybody. And you can imagine that, you know, this is autonomy. This is actually having this thing do something without a lot of human interaction. And you could even think about it, so it's got this closed loop around your entire floor of your school or office building, and when somebody wants it to stop in their office, they just put their book down or a coffee cup down, and then when they retrieve whatever they have for it, their mail or coffee, they just pop that back up and it's off and running. Okay, that is it. And so now you have your second check on the autonomy, meaning that you know everything really. You know all the main constructs of a program. You've seen how you use them with the tracker. You've seen how you can use both sensors to accomplish a pretty sophisticated tasks. And it's time for the robot challenge, which is where you get to put it all together.